equations, the simplest type. And so they're ones that you guys can do. Okay, separable differential equations. We're going to do this in 12 minutes, baby. 12 minutes. But of course, the great bulk of tonight's homework is just more use substitution. First of all, I got dy dx equals something. I want to remind you, if you got dy dx equals something, oh, is the thing on? So if dy dx equals something, that's a differential equation. That qualifies for a differential equation. But if it's going to equal something, oh, poo. I need my notes. Just a second. But, oh, I'm going to put the cart before the horse. Okay, if they give me something like this, dy dx equals xy, let's say, I can easily solve this because I can get all my x's multiplied by dx on the right side and all my y's multiplied by dy on the left side. Let me show you how this works. I'm going to multiply both sides by dx, and then I'm going to divide both sides by y. And so I want you to see now that I have gotten all my y's multiplied by dy on the left side and all my x's multiplied by dx on the right side. And when you can do this, then you have a separable differential equation. And now I can go ahead and take the antiderivative of it. I can take the antiderivative of both sides of this equation. The antiderivative of dy over y is the log natural of the absolute value of y. The antiderivative of x is 1/2 x squared. And now, you know when you take an antiderivative, you need a constant of integration, correct? So you could say this is log natural of y plus some constant of integration, c1, and this is 1/2 x squared plus some other constant of integration, c2. But the thing is, you can subtract c1 from both sides and make just one constant of integration. And so I am not going to require you to put constants of integration on both sides of this equation. All you need is a constant of integration on one side of the equation. You could put it on both sides, but your very next step would be to just combine them anyway. So all I need is a constant of integration on one side of the equation. Always, it ends up on the right side of the equation. It ends up with the x. And so now I could solve for y. I'll take the e to the power of both sides of the equation, and I end up with y equals e to the 1/2 x squared plus c power. And then if I wanted to solve for c, I could do so if they gave me an initial condition. Okay? This is an example of a separable differential equation. Let me ask you this. What if I gave you dy dx, so that's example number 1. What if I gave you example number 2? What if I gave you dy dx equals y plus 3? Is that a separable differential equation? Can I get all the y's multiplied by dy on the left side and all the x's multiplied by dx on the right side? Well, let's find out. Step 1, and I'm going to put the steps here. Step 1 is always to multiply both sides by dx. You need to get that dx over onto the right side. So I'm going to multiply both sides by dx. Is it possible for me to get my y onto the left side?
Yes.
Sure. What should I do to both sides of the equation?
Divide by y plus 2.
Yeah, good for you. Divide by y plus 3. So I got dy over y plus 3 equals dx. And now I've got it separated. I got all my y's multiplied by dy on the left side and all my x's multiplied by dx on the right side. Of course, there are no x's here, but I'm okay with that. And now I can take the antiderivative of both sides of the equation. This guy becomes the log natural of the absolute value of y plus 3, and this guy becomes x plus c. And now if I'm so inclined, I can solve for y. Y plus 3 equals e to the power of x plus c. And then I can say y equals e to the power of x plus c minus 3. And I'm happy as a clam. Alrighty. Hey, let's go for it. dy dx equals 2x times 1 plus y squared times e to the x squared. Please, yes?
Is that the only step that we should do?
Yeah, that's it. Oh, well, okay, yeah. Then step 2 is get y's multiplied by dy on the left, all your x's multiplied by dx on the right, and then number 3 is to take the antiderivative of both sides. And the right side gets the constant of integration. So that's it, that's the steps. But I want to see if you guys can separate this example. I'll call it example 3. I'll give you a minute. Everyone's here today. I'm hoping everyone has successfully separated the variables like that. And now you're going to take the antiderivative of both sides of this equation. All right. I'm so sorry, I'm going to cut you off here, but how many people, did you guys recognize this as inverse tangent of y?
I did.
Justin did, yeah. dy over 1 plus y squared is the inverse tangent of y. So here's inverse tangent of y. And then this guy, did anyone do u substitution to do that guy?
No.
No? That's okay. What should u be? What should I have my u be?
E to the x.
Not e to the x squared, no.
X squared.
X.
Yeah, just x squared. Just x squared. And I'll tell you, my clue that u being x squared is a good idea is because du ends up being 2x dx, and there they are, right? So I'm going to let u be x squared, and so du is going to be 2x dx. And so this guy becomes the integral of e to the u power du, right? There's my u right there. Here's my du right there. And so now I can take the antiderivative, and I get e to, I get e to the u. And now I'm going to have to back substitute. And I'll get e to the x squared. Oh, by the way, it's plus c. Okay. And then if I want to solve for y, I'm going to have to get the inverse tangent. I'm going to have to get the tangent of both sides of the equation. So I'll get the tangent of both sides of the equation. So the tangent of the inverse tangent of y just leaves me with y. And then I'll end up with the tangent of e to the x squared plus c. And then if they give me an initial condition, I can find c, yes.
Do we have to do substitution? Because it's obviously e to the x squared. Right?
Oh, I mean, are you smart enough that you immediately knew that the answer would be e to the x squared? Then don't do substitution.
Okay.
Yeah. Hey, you guys, if you're smart enough, to get a correct answer without substitution, don't do substitution. Like here, what's the answer? What's the antiderivative of the sine of 2x going to be?
Negative 1/2 cosine.
Yeah,
2x.
good for you. If you're that fast, then do that. Don't do substitution if you can do it in your head. My goodness. No, I want you to be rewarded for being clever. You know, this is Hogwarts, man. You're rewarded for being clever. Snape can't touch you. Okay, so, hey, let me give you one more. Let's see if you guys can just figure out what my strategy would be. I got dy over dx equals e to the x plus y power. I just want to see if anyone can figure out what my next step is before I start trying to separate the x and y. How should I rewrite that? What would you have me do? Is that pointing at it? Good for you. Gosh, Fatima, I should never doubt you. Just gotta never doubt. That's it, never doubt. How should I write that instead of e to the x plus y?
Oh.
Yes, Daniel?
EX times EY.
Thank you very much. Thank you for being so smart. Now can I separate the x's and y's? Heck yeah. Yeah, now I can. I got right dy equals e to the x, e to the y dx, and then divide both sides by e to the y, right? Or if I prefer, I can call it e to the negative y dy equals e to the x dx. And now I can take the antiderivative of both sides and etc., you know? Yeah. So I would just want you to try, you know, sometimes there'll be some demands on your cleverness to figure out how to get your x's on the right multiplied by dx and your y's on the left multiplied by dy. So anyway, hey, good luck on tonight's homework, and I want to remind you again, the answers are in the AP Calculus locker at school booth. Good luck. Thanks, Monty.